Have you ever noticed that when it rains a lot in cities, the streets often flood?
This is a common problem in cities such as Rochester. Flooding and closed beaches happen after big rain events because Rochester, like a lot of other cities, has an older system that stores rainwater in the sewers. But when there is a lot of rain, these sewers can overflow.
So what happens when the sewer system overflows?
Water enters the sewage system and it can be contained, and clean polluted water gets pushed into a nearby narrow body of water. In Rochester, the sewage system outlet is near Lake Ontario. This is extra concerning because Lake Ontario gives us fresh water that we use every day. Big rain events are worse in areas without trees and other plants to absorb water from going into the sewer. These will be areas that have parking lots, roads, and buildings.
This all might sound bad, but there are things that we can do to our cities to help deal with large rainstorms. A possible solution to this problem is to expand green infrastructure. Green infrastructure, also known as GI, are spaces that mimic the natural environment's abilities to capture, filter, and direct stormwater to be used by us or to safely re-enter our watershed.
This way, GI can turn rainfall into a resource instead of it becoming a waste that can harm our watershed. GI can help combat problems with water quality, such as pollution, and water quantity, like flooding. These problems are linked to the increase of impervious surfaces, like roads, that are the result of human development.
The Environmental Science Capstone Group has been working with the Rochester Museum and Science Center for the past 5 years to develop a better understanding of how we use and maintain green infrastructure over time. The museum's GI includes a green roof, bioretention areas, rain gardens, porous pavement, and rain barrels. Each installation has a role to play that aids in water management.
The green roof contains a bunch of layers of materials and soil that is designed to utilize rainwater for watering plants that live on the roof. Our group monitors the health and size of the plant communities on the green roof to evaluate the roof capabilities to support life. We have also collected water samples to analyze pollutants from stormwater runoff from the green roof to compare with traditional roof.
Bioretention areas and rain gardens on campus help funnel stormwater to areas where water can drain through soil, which act as a natural filtration system.
We monitor water quantity using different equipment such as loggers, which measures water height, and pendants, which record system overflow events. These help us track the amount of water moving through GI installations and to our sewer system, gaining a better awareness of how effective certain structures work to capture water.
Porous pavement, found on the sidewalks and parking lot, which are designed to allow any excess water to easily go through the pavement by trickling down or infiltrating into the soil below. We've conducted infiltration tests that time the rate at which water moves through the porous pavement to track and interpret its performance over time. The rain barrel are rainwater storage units that allow for water reuse.
We also work to improve the way we maintain all GI installations and equipment through cleanup events, which we were able to remove any debris from GI drainage areas, and we also ran quality assurance experiments on our pendants to gain a better perspective of what triggers a pendant to detect sewer system overflow in different areas of the RMSC campus.
There are still things we don't know about how GI works over an extended period of time, or how GI should be maintained in order to ensure environmental benefits. However, this 5-year-long project we are working on uses a combination of different monitoring equipment and techniques that provide us with data that can help us better answer these questions about the potential of GI.